Hello guys, in this video we are going to see a peculiar way of showing that for all t greater or equal to 0, ln 1 plus t lies between t minus t squared on 2 and t. Alright, so this is actually a past Polytechnic year 1 equation, and I already solved the problem in a different video, but I used a different method. So in this video I'm bringing to you guys another method that I discovered. Alright, so first we are going to define functions f of t, g of t, and h of t as such. Now we are going to check the difference between these functions, and then we bring out an inequality that always holds true for all these functions for all t greater or equal to 0. So let's first of all do the difference between f of t and g of t. So f of t minus g of t is 1 over t minus 1 minus t. If you simplify correctly, you're going to get t squared on t plus 1. But since t is greater or equal to 0, it means we clearly see that t squared will also be greater or equal to 0, and t plus 1 will be strictly greater than 0. So the ratio of the two positive numbers will also be positive, but it can be 0 since the numerator can be 0. So it means that this is greater or equal to 0, meaning that the original difference is greater or equal to 0. And the original difference greater or equal to 0 simply means that f of t is always less than g of t, or g of t is greater than f of t. Now let us do the other part where we compare g of t and h of t, their relative positions. So g of t minus h of t is 1 over t plus 1 minus 1. If you do the difference correctly, we are going to get negative t on t plus 1. But since t is positive, it means that in fact t is positive, right? T plus 1 will also be positive, so the ratio of the two will be positive, so negative sign in front there will make everything to be negative. We should still recall that it can be 0 since the numerator can be 0. So therefore means that this quantity is always negative, and this g of t minus h of t will always be negative, meaning that g of t is always less than h of t. So with these two inequalities, we have that g of t lies between f of t and h of t because of the transitivity property. If f of t is less than g of t and g of t is less than h of t, then g of t lies between f of t and h of t. The relation less than or equal to is a partial order relation, so it is transitive. Alright, so from there we can conclude that our f of t 1 minus t will be less than or equal to 1 over 1 plus t less than or equal to 1. These functions are bijective functions since they are all continuous and they are monotonous for all t greater or equal to 0. So we can integrate all through from 0 to t because all the functions are defined in that interval since t is greater or equal to 0. So we integrate all through from 0 to t, and then we apply our fundamental law of integration. Integrate 1 minus t, we get t minus t squared on 2 from 0 to t. Integrate 1 over 1 plus t, we get the ln of the absolute value of 1 plus t from 0 to t, and we integrate dt, we get t from 0 to t. If we fit in the upper and lower bounds and we subtract, we are going to get the required inequality that for all t greater or equal to 0, ln of 1 plus t lies between t minus t squared on 2 and t. Thank you for watching, and see you in the next video.